again. In this video, we begin our discussion on sampling and sampling methods. We're going to talk about what a population is, what a sample is, what is the process of sampling or of getting a sample from a population. And we're going to focus on the concept of a representative sample. And to explain what a representative sample is, we're going to have to delve into the concept of what a biased sample is or what sampling bias is to understand what makes a sample representative. So let's begin with what a population is. The population is the aggregation of all the elements, right, that we are interested in. Right? The aggregation of all the elements that we're interested in. And the population is defined by our research question, of course, in survey methods, right? For example, if the research question is how many undocumented immigrants in the United States have health insurance, then all the elements, right, that we are interested in are all undocumented immigrants. If our research question was, what is the obesity rate in the United States? Right? Or what percentage of adults are obese? Then the elements, the aggregation of all elements that we're interested in are all adults in the United States, right? That is our population. If we went smaller, let's just say we want to know what percentage of CHHS students live on campus, right? CHHS students, that's the aggregation of all the elements we're interested in, and that is our population, right? All CHHS students at CSUMB. Now, in most cases, we will not be able to observe the entire population, right? To answer a research question, right? For example, we are not going to ask every single adult in the United States, right, about their BMI. So we are going to, and we don't need to, thankfully, and thanks to statistics, we don't need to ask the entire population. We can ask a sample. We can take a sample from that population. It turns out that if we obtain a representative sample of the population, we don't need to observe the entire population, right? We can get very, very accurate observations of an entire population just with a sample. So a sample is a subset of a population. It is a collection of elements from a population. So for example, going back to one of our previous examples, if our population was all students in the CHHS major, then the sample would be a collection of CHHS students. Not all of them, right? All of them would be the population, but a subset of them, right, would be a sample. We can sample 100, we can get a sample of 10, we can get a sample of 50, whatever it is. But it's a subset of that population. Now, sampling is the process of obtaining a sample from the population, right? There are many ways in which we can obtain a collection of elements from a population, right? Now, and sampling is really the theory of these methods that we use to collect samples from the population. Now, the goal, if we want to explain what the population is like from a sample, the goal is to make that sample a representative sample. We want the sample to be as representative of the population as possible, right? So let's define what a representative sample is. A representative sample, right, is the result of an unbiased selection of elements from the population, right? Is the result of an unbiased selection of elements from a population, right? So the difference between the composition of a representative sample, right, and the population, if there is one, would be there just by chance, right? Not by a systematic selection of some objects over others. Okay, so when we obtain a representative sample from the population, that sample was obtained in a way where no elements had more chance than others of being selected, right? If in the sampling method, if in the process of selecting elements from a population to make our sample, we favor some elements over others, right? Then we are introducing bias in that selection process, right? And it doesn't need to be even conscious, right? If you are selecting the sample, right, based on some criteria that is not random, you are likely introducing some bias in that selection of elements, right? So a representative sample is a sample that was obtained in an unbiased way, right? So there was no systematic way of including or excluding elements of the population when we were selecting that sample, right? Now, this sample can look a little different than the population, right? Maybe in its composition, it's a little different, but it's still representative of the population if it was selected in an unbiased way. Okay, so let's see some examples. Let's say we have here the population of CHHS students. You see all these beautiful faces, yellow, green, and blue, right, and pink. So suppose I select this group, right? You see this group. Suppose I select them because they are taking my class, right? I select them because they're taking my class. Is that a representative sample of the CHHS major? Well, by selecting only the students that were in my class, I was introducing bias, right? Because I was including some elements in a systematic way and excluding others, right? I was excluding all the students that were not in my class, and I was including only those that were in my class. So it is not representative, right? Now, the sample is mostly these blue faces, right? But that has nothing to do with being representative or not representative. It's really different than the population, but it's not a representative, not because of its composition, but because I selected them in a biased manner. Let's look at this other example, right? Same population, CHHS students. Now, suppose I select this group, right, the top row there, because they volunteered to be in the study. Say I asked, I'm going to do a study and 10 students volunteered. Now, is that a representative sample? No, it is not, right? It is not representative because these students volunteered. So by volunteering, right, I'm looking at those that I'm systematically excluding those that didn't volunteer, right? Systematically including those that volunteered and excluding those that didn't volunteer. So this is not a representative sample of CHHS students. Now let's look at this third example. Suppose I select this column here because they were the first 10 CHHS students that walked into the classroom, or the library, if you will, right? Is this a representative sample? Again, no, right? Because I am systematically including only those that walked in and excluding those that didn't walk in time, right? So it doesn't matter that the composition, it looks like the population, let's say, it is non-representative because of the selection process that was not unbiased, right? So in summary, a sample is representative, right? When you select the elements, right, with no. So in summary, when you select the elements in the sample based on some criteria, right, that you made, right, your sample is biased, right? And if it's biased, it's not representative. When the elements select themselves, right, to be in the sample, your elements are also, the sample is also biased, right? Because there's a systematic exclusion of those who don't select themselves. So the sample is not representative in this case. So how do you get a representative sample? Well, the only way to get a representative sample or unbiased is by selecting elements using probability theory. When we don't decide who is going to be in the sample, or when elements don't decide themselves, right? When they are selected through a probabilistic process, that's when the sample is representative, right? Because anytime that we introduce a selection system, or the elements select themselves, they're introducing bias, or we're introducing bias, right? The last example, let's say we have a randomly selected sample of 10 individuals in the CHHS major. Let's say we put all the names in a hat and we pulled randomly 10 names, right? Now, this will be a representative sample. We didn't make any criteria on who to pick, or the elements didn't select themselves, right? It was all probabilistic in nature. Now, this sample that I randomly selected, right, looks different than the population, right? For example, 40% are orange, right, in our sample, but in the population, 65% are orange. That doesn't matter. If they don't look exactly the same, that doesn't matter. It is still a representative sample. Okay, the composition has nothing to do with whether it's a representative or non or a biased sample. It is the way in which the elements were selected that makes a representative or biased sample. So to finish up, a sample is a subset of a population. We study samples because in most cases it's impossible to observe the population, and we don't need to, because of probability theory and because of statistics and what we will learn in this course. We don't need to observe an entire population. We can get very accurate inferences about a population from a sample, as long as this sample is representative. Now, the only way to obtain a representative sample is by using probability theory to select observations randomly. And what makes a representative sample is not how similar it looks to the population or not. It is the way it was collected that makes it representative or not. Now, sometimes we cannot obtain probability samples for many reasons that we will discuss later. In the next video, though, we will start with representative samples, which are probability samples. So make sure you understand what a representative sample is. And in the meantime, I will see you in the next video. Thanks for watching.